Hold up. All right, so share my screen. Okay, and here is our warm up for the day. Oh. So there's 4 questions here. First, find the least common multiple of 12 and 8. Then you have to find the ratio of squares to diamonds and make sure you simplify that ratio. Then you're dividing 4 and 59 hundredths divided by 3 hundredths. And then finding all the factor pairs of 60. Factors are the numbers that multiply to 60. So all the numbers that multiply to 60. Okay, so I'm going to give you guys about, let's do 7 or 8 minutes on this. Okay, so you need to count how many squares there are. So you're going to count how many diamonds. Okay, so you're right, 15 first. And then you can make a ratio you think about that. So that's a ratio, 15 squares for 1 diamond, and then you should simplify it. What number does it? So you have to simplify a ratio, just like you simplify a fraction. You just figure out what number goes in the middle, 15 and 20. How many? What number will go in the middle? 4? 4 will go into 15. I can use it, but I just can't use it as simple. So it's supposed to be just 2 ones.
Are we supposed to simplify number 2?
Yeah, simplify number 2. So this is my one to the 3 village people. And you divide them both evenly by 2. No, that. 5 is the most, so you can divide by 5. So you're right, divide by 5. So you're divide 15 divided by 5 and 20 divided by 5. I'll get my. Two, 20, right? Here's the y, 15 divided by 5, and 20 divided by 5, equals 5. So 1 is 15 divided by 5. And think about it the opposite way too, like 5 times what is 15? If you stick one by 5, how many times do you stick one? 15 to 5 times 3. 3 is what you divide by. 15 divided by 3, 5 is 3. And this one, 20 divided by 5 is 4. So this is our final answer. list that you see, there's 4. Try to get a couple. Okay. Okay, we're gonna do about 2 more minutes.
Miss Jones, the Cardinals smoked the Cowboys last night.
That's good.
Yep.
If you're a Cardinals fan.
Yeah, they had So Ezekiel Elliott, he plays for the Cowboys. He's a running back, the guy who runs the football, and he dropped the ball like 2 times, and the Cardinals recovered it like twice. And then they smoked them. It was like 30. No, it was 31 to 9, I think. And they didn't score till like the very end of the game.
Wow, that's pretty good.
Like the Cowboys didn't.
Dang.
They only scored a field goal.
Alrighty. I think we are ready to go ahead and work on these problems to review. So, let's start with number 1. Can you guys online see the whiteboard pretty well? Is it good?
Yeah.
Okay, so to find the least common multiple, we need to do our factor trees first. So our factor tree for 8 and 12. So let's start with 12. What numbers multiply to 12?
6 and 2.
6 times 2, good. So let's do 6 and 2. Can I circle either of these? Are they prime? The 6 is prime? The 2 is prime. But we know that more things can multiply into 6. So what multiplies to 6?
3.
3 and 2. We know that 2 is prime. Is 3? Yep. The only thing that multiplies to it is 3 times 1. Next, we have 8. What numbers multiply to 8?
4 and 2.
4 and 2. We know we can circle the 2, but what multiplies to 4?
2 and 2.
2 and 2. Okay. Now we need to do our, what is it called? Matching. The least common multiple goes on top, GCF on bottom. I'm just going to put the numbers for 12 on the top row. So we have a 2, a 3, and a 2. So we've used these ones. Now we need to do our match and match. Can I match a 2 to the bottom row?
Yes.
Yep. We can match 1. What about another 2?
Yes.
There's 1 more to match. Can I match this final one? No. So where does it go?
On top.
On our top row. And then we can multiply all of our numbers together. So we're going to multiply. So we need to do 2 times
24.
2 times 2 times 2. I heard it. What was it?
24.
24. 2 times 3 is 6. 6 times 2 is 12. 12 times 2 is 24 is your final answer for the least common multiple. So the first multiple that 12 and 8 have in common, if you list all the factors out, all the multiples, is 24. Okay? Number 2, we are comparing squares to diamonds. I don't have it still up, but how many squares were there?
20. Yeah, 20.
So there were 15 squares and there were 20 diamonds. So now we have a ratio. For every 15 squares you see, you're going to see 20 diamonds. But we can simplify this. What number goes into both 15 and 20?
5.
Good. So what is 15 divided by 5?
3.
3. And 20 divided by 5? 4. Can I simplify 3 to 4 any further?
No.
That is our final answer right there. 3 to 4. Good. Now number 3 over here, we're dividing some decimals. First thing we need to do is move our decimal. We have to bounce the ball to the wall. So we need to take the decimal on the outside and move it twice to the wall. If I move it twice on the outside, good. You have to move it twice on the inside as well. So we're going to move it 1, 2 times here. And then where does this go? On top. On the roof. Good. Now we just need to start dividing. Ignore the zeros at the front. Does 3 go into 4?
1 time.
1 time. Good. Subtracting, get 1, and we drop down our 5. Does 3 go into 15? Yes, 1 time. Good. 5 times, and it goes in evenly, so we're left with 0, but we can drop down our 9. Does 3 go into 9?
3 times.
3 times. Good. And that goes in evenly, and we're good. So our answer here is 153. How'd you guys do on that one?
Good.
Good. All right, and our final one, the factors of 60. Factors are what? What's a factor?
Numbers that multiply to 60.
Good. All the numbers that multiply to 60. So let's start with 1. 1 times what is 60?
60.
Good.
2
What
and
about
30.
2? 2 go into it?
2 and 30.
Good. 2 and 30.
3 and 20.
Good. 3 goes into it 20 times. What about 4?
Yes, 15 times.
Good. 4 times 15. What about 5?
Yes, 5 and 12.
12. 6
Yes, 6 and 10, and that's the last one.
times 10. So 7 does not go into it. Does 8?
I don't think so.
No. What about 9?
No,
Yeah. No.
9 doesn't go into it either. Because 9 times 7 is 63. And so it'd be 9 times 5 is
I lost.
9 times 6 is 54, plus 9 more would be 63, so it wouldn't be able to.
Yeah, I'm good.
I drew
Okay.
a monster. Look at my
Are we
monster.
still good? My computer lost connection for a second, so we're still good on your end?
Yeah, look at my monster.
Yeah.
Good. Let's see your monster. Nice.
Yep.
It looks like a weird pig.
Yeah, it's a demon pig.
A demon pig. All right. Sounds good to me. Okay. So that was our warm-up. We talked about absolute value yesterday. I want to do like maybe 1 or 2 questions with absolute value just to practice really quick. Should have put that in the warm-up, but oh well. So just really quick, let's look up at my screen. Let's say I want to take the absolute value of -8. And remember, because I think this was an issue for a lot of you guys on the review yesterday, an absolute value is the straight lines around a number. These aren't actual numbers. It's just the sign that tells you that you need to take the absolute value. So what is the absolute value of -8?
8.
Good. It becomes a +8. It just goes positive. It's the distance from 0. And
What were
distance
the
is always
what were,
positive.
what were the scores on the tests yesterday?
I have not looked. I'd have to look
Oh.
individually. Sorry I didn't grade it for you.
That's all right.
Let's try another one. Let's say I have the absolute value of 7/8. What does that become? Absolute value of 7/8.
It's the same.
Yeah, just 7/8.
7/8. Good.
This is like
Um,
first graders could learn this.
First graders could potentially. They
pretty complicated.
yeah, they get confused with the negatives. So that's
Oh yeah, that's true.
Let's
They
say
can learn this. They can learn the stuff that's not the negatives.
maybe. Okay, let's do some comparing. Let's do negative
-16.
negative 2500 and negative 5/10. So first we need to take our absolute values. What's the absolute value of negative 2500?
25 tenths. I mean hundredths.
Good. It goes positive 2500.
And then it's just
And then what is the absolute value of negative 5/10? Turns into a positive
5 tenths.
5/10. Now we need to compare. Is 2500 less than, greater than, or equal to 5/10? I'm hearing different answers. What about online?
Greater
Okay, so
0.5 is bigger. Way bigger.
okay, so it's gonna look like this. 2500 is less than 5/10 because you need to compare the place values. Okay, the zeros are the same. We can't compare them, but we can compare the values in the tenths place. We know that 2 is less than 5, so this means that this decimal has to be less than the other one. Okay? All right. Let's talk about, or let's do, we have another PowerPoint that's kind of like some interactive notes. So we're going to work on that now. Let's take this down and sit. Okay. So I'm going to share my screen and get it pulled up. It should be posted on Google Classroom. All right. So on Google Classroom, while we've been talking, we had an assignment post in math called Comparing and Ordering Rational Numbers.
It posted before we even started. I saw it on it.
Yeah, it probably did. So we're going to go ahead and open that up, and it looks like this. All right. No, you don't have to highlight the answers, but we will be typing into it, so I'm not going to present it, like, I'm not going to make it big. Like
Wait,
this.
are we doing ratios in this slide?
No. Rational numbers are different than ratios.
Wait, are they just absolute values, basically?
We're going to talk about rational numbers, because rational numbers are a lot of things. Okay, I'll give you a minute to get that pulled up. Yes, you can.
During the hour break, I took a slingshot that I had and a glass bowl, and I shot it with a marble.
Oh my gosh. Did it break?
Yeah, it exploded.
That's kind of cool. Were you wearing protective glasses?
Nope, I was wearing my normal glasses, but I was standing back like at least maybe 8 feet.
That's good then.
But I missed it like the second time.
Ah.
My little brother, who's 6, got mad because he couldn't hit it.
Alrighty, so let's go ahead and go over these. I don't think it'll take us too long. We'll see. So we're going to be comparing and ordering rational numbers. Now, if you look behind me, can we still see behind me? Yeah. What we did right here of comparing them of less than, greater than, or equal to is kind of what we're going to still talk about today with comparing. But ordering means that we're going to put numbers in order from least to greatest. But we're not going to make it as easy as having it be all decimals or all fractions or all percents. We're going to give you decimals, percents, and fractions, and you're going to have to order those. So we're going to talk about the process of how to do that. So slide number 2. Let's talk about what a rational number is in the first place. Rational number is basically any number that like stops. It can be a whole number, a decimal, a fraction, percent, to almost any number. The only thing that a rational number cannot be is a decimal that repeats. So if it's something like 0.33333 or 0.55555, it's not a rational number. So essentially it's any decimal, negative number, positive, whole number, fraction. As long as it's not a repeating decimal, it's a rational number. There's some exceptions, but for the most part, that's what we're working with.
Even if it's a negative repeating decimal?
Even if it's negative, it's still a repeating decimal, so it's not rational. Okay. So it's basically any number. We just call them rational numbers. There's different types of numbers. There's a whole Venn diagram about them, but I think you do that in 7th grade, right? Maybe 8th.
I don't know, this was like my high school math, so I have no idea what junior high math was like this day.
Right. So rational number is pretty much anything, and we've worked with all rational numbers. You just haven't known that they're called rational numbers, because if we look at our examples here, 4 and -4 are integers. We've worked with integers. 5/6 is a fraction. We've all worked with fractions. -2 and 29/100 is a decimal. Whether or not it's negative or positive, we still know how to work with decimals. And percents. We haven't done a whole ton with percents, but we're working on that this year. So these are all things that you've seen before. It's just that now we're going to call them rational numbers instead of just numbers. Okay? Miss Daphne?
I have a really weird question.
She has a really weird question. Okay.
Okay, so a fraction is 1/3 still rational, even though it as a decimal is irrational.
I don't know.
But you don't know what is the bathroom?
Yes. I want to say yes because it's a fraction, but we might have to Google that one later to check. Okay.
What was the really weird question?
Her question was, so 0.33333, if you were to write that as a decimal, or sorry, as a fraction, becomes 1/3. So she asked if 1/3 is rational, but the 0.33333, which is the same number, just in a different form, is not rational. So we're going to check to see if it's in fraction form, if it's rational or not.
I doubt it though, because it's a fraction. But who knows? It could be wrong.
I
But
don't
then
know.
any fraction wouldn't be it, because all fractions have a decimal to go to.
It is rational? Okay, so the answer is yes. If it's in fraction form, it's a rational number. But once you do the division and you get 0.33333, it's not rational anymore because it repeats. Okay? So let's look at slide number 3 and just do some yeses and nos. Are these numbers rational or not? If it's yes, we're going to type yes. If it's no, we're going to type no. So we have for number 1, the decimal 3 4/10. Is it rational or not?
It is.
It is. Why? Why is it rational? Good, because it does not repeat. It's not a repeating decimal, so it is rational. Good, let's look at number 2. This one we have a fraction. Is it rational or not? The people in class are saying yes, it is, and they are correct. It's a fraction. Any fraction is rational.
Can we do like a Y for yes and a no and an N for no?
Yeah, that's fine.
Okay.
Okay, let's look at number 3. 5.66666666. That looks like it's just going to keep going on and on forever. Good,
No.
so it is not a rational number because it's a repeating decimal. Good. Our next one, number 4, we have 4.363019. I'm not even going to try and say that as a decimal. I don't know how far out it is. It's a lot. I'm not going to say it. Is this decimal repeating? Does it repeat numbers? No.
Yes.
It's not repeating, so is it rational or not?
Well, wouldn't any decimal like that, like, because you can repeat numbers forever.
So the way that it shows it, I'm going to write it behind me, okay?
Okay.
So the way that it shows rational, shows that something is repeating. So if we take that 5.6, the way that we show that the 6 is repeating for number 3 is we put a line over the top of it, and it means that the 6 is repeated over and over and over and over and over. Okay? If we look at number 4, so it's 4.363019. Because there's no line over any number, it's saying that none of these numbers are repeating, and the decimal just ends right there. It just stops.
What if you had like not the same number, but you still had a repeating thing at the top over the
Okay, so if we were to show that this one is repeating, so let's say there's a line over the 1 and the 9.
Okay.
That means that after it does 363019, the 1 and the 9 is just going to keep repeating 1919 over and over and over. That becomes repeating, and it's irrational. It's not rational. Does that make sense?
Yeah, that's what I was wondering.
Yep. So if you don't see a line over a number anywhere, it's not a repeating decimal, and the decimal ends, and it is a rational number. Okay?
I have another really good question.
Okay, Miss Dolphin has another weird question.
So pi is technically not a rational number, though, right?
Yeah, but I think that's like one of the exceptions
Okay.
because it's such a random.
I never made it that far in pi, so I didn't know if at some point.
It does not repeat. What?
What if you had? I got one.
Yeah,
What
what's
if
up?
you had instead of the number behind the behind the decimal? What if you had like repeating numbers in front of the decimal?
That one is not possible. I've never seen a number like that. Like where this is repeating over here.
Yeah, like it just keeps going.
Yeah. In that case, then after the decimal, it would be like 44444. So
it would not pass the decimal at all.
No, it wouldn't. So you can't really have a repeating whole number. That's not a thing.
Unless it was like a number inside of your head that you created.
Maybe. All right, and then number 5, we have 576%. Is this rational or not? It is rational. Okay, it is a rational number. All right. So now that we kind of have an idea of what a rational number is, let's look at slide number 4 and talk about how to compare them. We are going to use a standard that we learned previously, where we talked about changing decimals, percents, and fractions into each other. So fractions can be changed to decimals and percents. We know that decimals can be changed to fractions and percent. I said that wrong.
I forgot what that's called.
Yeah. Conversions. You're converting.
Yep, that's right.
Yeah. So basically, what we're going to do is you'll get a list of numbers. So let's say we have something like, can you guys still see behind me? We're good?
Yeah, just a little
We
bit.
have like 3/4 and 0.5 and -2. So we have these 3 numbers. We're going to figure out how to put these in order from least to greatest or greatest to least, depends on what it asks for. They're not all in the same format though. One's a fraction and these 2 are decimals, because technically -2 could be -2.0, right? So these are both decimals. What you need to do is change them all to the same format. They all need to be decimals. They all need to be fractions, or they all need to be percents to be able to put them in order from least to greatest. So that's where our conversions come in play. In this case, I would say we'd change the fraction because we only have to change 1, and then we can put them in order from least to greatest. So that's the process we're going to do a couple times to practice. Okay, so number 1 here says convert all the numbers to a common format, the same format. So all fractions, and if you change them to fractions, they all need to have the same denominator as well. If they don't have the same denominator, you can't compare them. They have to have the same bottom part of the fraction. And then you can either change them to all decimals or all percents. To be honest, my favorite way to do it, and I think the easiest way to do it, is to make them all decimals. I think that going to decimals is the easiest. and the easiest way to compare them and put them in order. Okay? Once you have them all changed to a common format, you do number 2 here, which says to put them all in the required order. This is probably the part where I see a lot of you guys mess up the most. You may get all of your conversions right and you have them all changed to decimals correctly, but you have to make sure you put them in the correct order. If it asks you for least to greatest, you got to put them in order from least to greatest. If it asks you for greatest to least, it has to go in that order. Sometimes the assumption, and what I see mostly with previous years, is that you automatically put it in order from least to greatest and just leave it, no matter what it asks for. So make sure you read the question to see which order it wants you to do it in. And then finally, once you have them in the correct order, you rewrite them again using the original format. So put them back into the original fractions, decimals, and percents that they were, just in the correct order after that. Okay? We're going to do a few examples.
Remember what they were last time?
Well, you'll have it written down. Yeah, it'll still be written there for you. So we're going to go to slide number 5 and look at a couple of these. The first ones we have all decimals, because like I said, I find it easier to work with decimals, so we're going to talk about putting these in order first, and then we'll look at some that are not in order. So we have 0.402, 0.42, 0.037. Okay, so we have our 4 decimals here. Can we see all of them on the board? Okay, first things first, we should look at the ones place to see which one is the greatest. So we have a 0, a 0, a 0, and a 1. Which one is the greatest out of those? The 1.2. Okay, so we've used that one. Now, let's look at our tenths place. We have a 4, and a 3. Which one's the greatest?
0.42.
Okay, so we have 2 that have a 4. So if both have a 4, we need to look at the next place value. We have a 0 and a 2. So we have 40 and 42. Which one's greater? Good. 0.42. We've used that one. Then we know that the 4 is greater than our 3, correct? So then we would have 0.402. And our final one is 0.375. Now, I did something wrong. What did I do wrong? Read the directions. What did I do wrong? Not rewriting it. Good. So I put these in order from greatest to least. So what order should I have put them in? Least to greatest. So let's rewrite this correctly. Our one that was the least is 0.375. Then our next least greatest was 0.402. And we had 0.42 and 1.2. Okay, so I even did the mistake that I just told you guys not to do, where I put them in the correct order, just opposite, right? So I'm going to give you guys, let's say, 2 minutes. I want you guys to try number 2 on your own. Order those decimals on your own. Okay, use the same process. Look at the place values and put those in order. What do the directions say? So then you're gonna go least to greatest. Okay, we're gonna do about 30 more seconds, and then we will do that one.
This one is kind of tough because it has like the same questions, but it's like harder to like it's harder to decide. Well, not decide, harder to tell.
We'll talk about how to tell. All right. So this one, like Dallin said, is a little bit tougher. So let's start off by looking at the ones that we know are less, right? The 0.32 and the 0.321. Those are less than the 2.5s because the whole number is smaller, right? 0 and 2. So let's start just by looking at the 0.32 and 0.321. Now, zeros are the same. We can't compare those. Our next place value is the same. We can't compare those. The next one is the same too. But now there's not something else to compare. But what can I add at the end here that's not going to affect it? Good. A 0. So really, this is 320 and this is 321. Which one is less, 320 or 321? 320 is less. So what's our first number that's going to go there? 0.32. Then what's going to go next? 0.321. Good. And then we can do the same thing when we look at the 2.5 and 2.52. Okay, our 2's are the same in the 1's place. We can't compare that. We can't compare the 5's because they're the same. But what can I add after the 5 to compare? A 0. So which one's less, 2.5 or 2.52? 2.5, and then we can put our 2.52. You guys see how that works, that you can add zeros if you need to at the end of these decimals? Hit the undo button up at the top.
Mine
Right.
was different. Hang on, let me look at mine. Oh wait, never mind. I got mine right.
You got yours right?
Wait, why would the 2 be at the end? It's in the hundreds place though.
Because you can add a 0. So if you look at my screen and you look behind me, they're the same in the 1's place. They're the same in the 10th place. But if you add a 0 to the end of the 2.5, 0 is less than 2 in the 100th place. So it goes
Wait,
before.
so wait, doesn't 0 count as nothing though?
Yeah, but it's like saying 250 instead of 252.
Oh.
Yeah. Okay. All right. So we have, let's see, what are the next slides? More practice, more practice. Let's do this one. So this slide number 6, comparing these, but they're in different forms. We need to change them to the same form before we can compare them. So let's start with number 1. We have 10%. We need to figure out if that's greater than, less than, or equal to 1/8. So we either need to change the 10% to a fraction, or we need to change the 1/8 to a percentage. Which way do we want to go? Doesn't really matter.
Can I get a drink real quick?
Yeah, go ahead, Don. What do you guys think? Should we make the percent a fraction? Take the 10% and let's make it a fraction? Okay. So to take 10% and make it a fraction, What do I do? Good, put it over 100 and get rid of the percent. But we can simplify this by 5, and oh, there's a bigger one. We can do it by 10 as well. So we simplify this by 10, and we get 1/10 is greater than, less than, or equal to 1/8. But we can't necessarily compare them just yet. They don't have the same denominator. How do we get a common denominator with fractions? Good, you need to multiply by the opposite denominator. So we need to multiply this fraction by 8/8, and we multiply this fraction by 10/10 because you take the opposite denominator and multiply them. So what's 1 times 8? 8, I'm gonna write it up here. 8, and what's 10 times 8? 80. Is less than, greater than, or equal to, what's 1 times 10? 10, and 8 times 10? 80. So now we need to look at our numerators. Is 8 less than, greater than, or equal to 10? What? 8 is good. 8 is less than. So when you put it in your thing, 10% is really 8/80. 1/8 is 10/80. And you can compare them and say they're less than. Kind of a lot of work, huh? A little bit. Okay. Do you guys want to try number 2 and 3 on your own?
Yeah.
All right. Let's take about 4 minutes. Try number 2 and 3 on your own. See if you can get those right. Change them to the same format. Both decimals, both percents, or both fractions so you can compare. All right. Do we need another minute or want to go over them? All right, let's go over them. So number 2, we have a decimal and a fraction. This is the one where I would say that we should change the fraction to a decimal to compare them. It's going to make it easier. So we have 0.5 compared to 3/5. My initial thought is that change the fraction to a decimal, and it makes it the easiest. How do you change a fraction to a decimal? You have to divide the top, which is 3, divided by the denominator, 5. Can you guys still see that?
Yeah.
Okay, good. Does 5 go into 3? No. So we have to add a decimal and a 0 and bring it straight up. Does 5 go into 30? How many times? 6 times. So our decimal that we're comparing here is 0.5 compared to 0.6. Is 0.5 less than, greater than, or equal to 0.6? Less than. Good. Okay. And then number 3, we have a decimal and a percent. So we either need to change our decimal to a percentage or a percentage to a decimal. It doesn't matter which one. 0.7 compared to 170%. Let's change the decimal to a percent. How do I change this decimal to a percent? We don't need to divide anything. All we got to do is move our decimal. How many times do I move my decimal though?
2.
Twice. To the left or the right?
Right.
To the right, twice. And if I moved it twice and there's nothing here, what do I have? A 0. So this is 170% compared to 170%. What do I put in that blank? An equal sign. Okay. All right. How are we feeling about this so far? The comparing. Doing good? It's kind of a difficult one, so we're going to work on it throughout the week. Now let's see. So we have 4 problems left. We only have about 10 minutes. So we're going to do just this last slide, slide number 7. We're going to do, okay. Yeah, we'll do number 1 together. And then I'm going to have you guys work on number 2 on your own. So we're going to practice it all together. Now, we have a percent, a decimal, and a fraction. What do we want to change them all to? It's kind of up to you. You can change them to whatever you want, but we need them all to be the same. So should we change them all to percents, or all to decimals, or all to
0.66666? You froze.
Oh, are we back?
Yeah, there you are.
Okay,
You froze. It looked like you were a statue.
I am a statue.
Wouldn't on number 2 be like since it's like the same as number 3, wouldn't it just be like 0.66666 or something like that?
Which one are we looking at? Number 7? Slide number 7?
Yeah, I'm just
Okay.
talking about number 2 because I looked at that and I'm like, oh, it might be this, like that was 1/3.
I'll have you guys do number 2 on your own, but for right now, well, I'm gonna talk to Ms. Bratt for a second. Take 135%, change that to a decimal for me.
I just have to keep checking. I know. Are any of these in person? And here today, I like this here. Did I test here? We're about to go to lunch, but what time do you go to lunch? At 11. Oh, you know what? Probably and I'm gonna do lunch later in a little bit, so. Anytime in the afternoon is good. Yeah. So Alex is here, so is Skylar. Oh, good. And then if the others get online and they could come to a meeting, I could test them all at the same time in a meeting. Okay, I can probably put that in. Okay, all right, we'll work on that this afternoon.
Sounds great. Thank you.
Thank you.
All right. Yoshi? Yes, you may go use the bathroom. Yes, you can fill through it. Okay, good. Did somebody get 135% and change it to a decimal?
Wouldn't it be like 1.35?
Good. You take your decimal at the end and move it twice back, and you get 1.35. Good. 13 5/10 is already a decimal. You can leave it there. 13.5. But now we need to take 8 3/5 and change that to a decimal. Honestly, the 8 can stay there. We just need to figure out what the decimal that goes behind it is. So we need, not a 0. We got to change 3/5 to a decimal. We did that earlier, 3 divided by 5. And we got what? 0.6. So this is an 8.6. So now we need to put them in order from what? Least to greatest or greatest to least? Least to greatest. Looking at our decimals, which one is the least? Look at the ones, please. That's the least? Well, yeah, just start by looking at the whole numbers even. We have a 1, a 13, and an 8. You can almost ignore the decimals here and just put them in order using the whole numbers. What's the least here? 1, 13, or 8? 1. So that's, so 1.35 is first. What's our second one? 8.6. And then finally we have 13.5, right? Okay. So now that we have these in the correct order, we need to rewrite them using their original format. 1.35 was not what it was originally. What was it originally? 135%. So that's our first one. Then we have 8.6. But again, that's not what it was originally. What was it originally? 8 3/5.
Wouldn't 135% be equivalent to 13.5?
No, because you moved it twice.
Oh,
2 decimals over makes it 1.35. Okay. And then our last one that's left was 13.5, and that was already in the correct format, so it stays 13.5. Okay. Now, we have a few minutes. I want you guys to try number 2 on your own here. Try and put number 2 in order from least to greatest. Okay, so change them all to the same format. Put them in order from least to greatest, and then put them in their original format again.
I left my marker downstairs.
Dallin, come on, man.
That's probably why I talked about having stairs at the bottom, all the way down to get something.
I'm just opening the whiteboard.
Okay. Oh, wow, they made this one difficult. Nope. Well, I mean, I did, but I copy and pasted them. Okay, so let's talk about this one. So we have 1/6, 16.7%, and 0.16. So 1/6, 16.7%, and 0.16. So if we change them all to decimals, I actually started doing this one, 1.6 or 1/6 changed into a decimal is 0.16666, and it just keeps repeating forever. If we change 16.7 to a decimal, we need to take our decimal and move it twice to the right or twice to the left. The left, so that's 0.167. And then we have 0.16. So these are all very, very, very close together, right? Okay. We need to put them in order from least to greatest. So I'm going to put them on top of each other so we can compare. Okay.
It's easier to do that.
To put them on top of each other? So I put them on top of each other and added some zeros. So if we look at it, the zeros in the ones place are all the same. Can't compare those. We can't compare the ones. They're all the same.
You can't compare the 6.
Can't compare the 6s because they're all the same. But now we have differences in this place value. Which one is the least? The 6, the 7, or the 0? The 0. So this is our first one, number 1. That will be our first one that we write down. Okay, so we've used this one. Now we have a 6 and a 7. Which one is less? The 6. This top one, which is this one. So this will be our second one that we write down. And then that means that the last one left has to be our third one. So if we were to write this in order on our thing. Our first one is the decimal that was already there, 0.16.
Miss Jones,
Yeah,
I might lag out. I'm
that's
like,
right. We're gonna get going right after this too. So
right.
our first one is 0.16. Our second one is the fraction that we changed, which was what fraction? 1/6. And then our last number left was our percentage, 16.7%. So that one was kind of a long one, or a harder one. You have to kind of compare those pretty closely. If you have the desire, you may go and finish up and try numbers 1 and 2 on the last one. Not necessary.
That last one was a lot of 6s.
It was a lot of 6s.